4,000 years ago, Finnish travelers made a remarkable discovery. By gliding across the ice on specially carved animal bones, they could cover distance far more quickly than trudging through the snow. And it's no surprise since the smooth surface of ice exerts almost no force of friction on objects moving across. Of course, the Finnish wouldn't have known anything about forces or motion, but you will by the end of this video. Motion can be summed up by three simple rules known as Newton's laws of motion. Law number 1. If all forces are balanced, objects will keep going at the same speed. Let's say we have a skater standing on the ice. She's not moving, so her speed is 0 meters per second. If no new force is introduced, the skater will stay at rest all day and all night, forever and ever. If the skater is accelerated to, let's say, 5 meters per second, she will continue traveling at this speed forever, just like when she was at rest. In physics, we call an object's resistance to changing its state of motion inertia, which has everything to do with an object's mass. In fact, the definition of an object's mass is not how heavy it is, but how much inertia it has. In other words, mass represents how much an object resists acceleration.
So the more mass an object has, the more force it takes to speed it up or slow it down. This relationship is summed up by law number 2. The net force applied on an object is equal to the object's mass times the acceleration caused by the force. Think of force as being fixed. Mass and acceleration always have to multiply up to the same thing, so an increase in one of the values always means a decrease in the other. What does this mean? Well, if you have an object with a lot of mass, it takes a great amount of force to cause even a tiny bit of acceleration. On the other hand, if you have an object with very little mass, that same amount of force will cause a much greater acceleration.
So far, we've talked a lot about the rules that govern an object's motion, but how does a force cause motion in the first place? Newton's third law states that for every action, there is an equal magnitude and opposite direction reaction. When the skater pushes backwards on the ice applies an equal magnitude, forward force on the skater. It's this forward force of the ice that pushes the skater forwards. When the skater pushes down on the ice pushes upwards, allowing her to jump.
Now that we've learned all about Newton's three laws of motion, let's apply them to the real world of skating. Law number 1 states that objects resist changing their state of motion, and this makes it very difficult for a skater that's moving very quickly to stop. By adding a rubber pad to the heel of the skate, a skater could introduce a resistive force of friction onto the ice, allowing them to slow down much more quickly than the traditional method.
We learned from Newton's second law that the more mass an object has, the less it will accelerate with a given force applied. In a competition, wouldn't this give lighter skaters an unfair advantage? An advancement could be to adjust the mass of the skates proportional to each skater so that all competitors move using the same acceleration. This would make competition more exciting and challenging as it would rely on pure technique.
Finally, as we learned from the third law, the skater can only move forward because the force they apply to the ice is being applied back, pushing them into motion. This concept is especially important when designing skates for different sports, as each sport has a different focus. For instance, skates used in speed skating have a hinged boot, allowing part of the blade to detach from the skater in certain movements. This focuses most of the force to the blade, allowing for greater speed. Another example is the toe pick, a component of figure skates. The jagged edge lets the skater maximize the amount of force they apply into the ice, and so the maximum amount of force is also being pushed back. This allows the figure skater to propel themselves upwards and do all sorts of jumps.
Today, skating unites communities through sports such as hockey, curling, and figure skating. It's pretty inspiring to think that none of these things would exist if not for the ingenuity of our Finnish ancestors, which goes to show the power of learning something new.